welcome to tonight's show. Our top story tonight is on research done by a group of scientists who have discovered a potential treatment for waterways contaminated by a common pesticide. Organophosphate pesticides, also known as OP pesticides, are used not only as pesticides but as nerve agents too. They present a huge risk to the environment as well as humans. It is estimated that thousands of people die or suffer from OP pesticide poisoning every year. The use of these pesticides also often leads to contamination of waterways nearby where the pesticide is being used. In order to get rid of these toxic compounds from the environment, the use of enzymes as a means to do this has been proposed. This is known as bioremediation. Professor Connie Padalecki will now explain the mechanics behind the research done.
GPDQ is an enzyme that was found to be capable of hydrolyzing or breaking down the OPs. GPDQ was considered ideal as a bioremediator due to it being versatile in the way it can break down fairly non-reactive OPs, as well as di- and monoester substrates. Its ability to degrade a toxic product from a particular nerve gas, and the fact that the enzyme can function over a fairly large pH range. In order to significantly enhance the catalytic activity of GPDQ, it was mutated, which further makes it perfect for bioremediation. The problem that was faced in the research was immobilizing the enzyme and binding it to a magnetite nanoparticle, so its degradation properties can be applied to specific areas or substances. This was done through binding the enzyme to a metal ion, in this case cobalt, then attaching it to modified magnetite nanoparticles using glutaraldehyde. The results from this research show that when tested in mimicked water filtration conditions and over periods of 7 and 120 days, the enzyme was active on the nanoparticles and was able to be stored over an extended period of time in its immobilized state without any activity loss. In addition, the concentration of the OP substrate used to test the effectiveness of the enzyme decreased over time, and the activity towards the substrate was generally unaffected by the concentration of OP the enzyme was placed in. Whilst the research already done is not enough for it to be trialled as of yet, it does provide evidence that GPDQ bound to magnetite nanoparticles can remain active and does break down OPs. It also shows evidence that enzymes can remain active and functional even whilst immobilized on the nanoparticle, and is able to be stored immobilized for prolonged periods of time without any loss of activity.
With bioremediation of contaminated waterways, damage to the environment as well as damage to humans could potentially be decreased, resulting in fewer deaths or illnesses due to OP pesticide poisoning. That's all for tonight's show. Thank you and good night.